Okay, so last Monday when we first introduced rational functions, I did an example like this where we found the vertical asymptotes, the horizontal asymptotes, the intercepts, and then we graphed it. And then from the graph, once we had the picture of it, then we decided, or I asked you to figure out the intervals of positive and negative. So where the function was above the x-axis and where it was below it. Okay? Today what we're going to be doing is the exact same thing, identifying where it's above the x-axis and where it's below it, but without graphing it, just doing it algebraically. Okay? So what we need to do is to determine the x values where the function can change from a positive to a negative. So that obviously can happen at an intercept, right? Because if the function's 0, then it has to go up or it has to go down. Make sense? Okay. Where else can the function change from a positive to a negative? The intercept and the, anybody remember? Or, right, the vertical asymptote. Okay, so what we need to do, first of all, is identify the x-intercepts and the vertical asymptotes. Now that's pretty easily done. So to determine the x-intercepts and the vertical asymptotes, how do I determine the x-intercepts of a rational function? What do I do? Yep. And so essentially what am I doing? I'm setting the numerator equal to 0. You set y equal to 0, right? So you're right. So take whatever's on the top, excuse me, and set it equal to 0. So x equal to 3 is the intercept. How do I find the vertical asymptote? I think you guessed, George. Thank you. So whatever's on the bottom, you set it equal to 0. I get x is equal to -2. So those are the two spots where the function can change from a positive to a negative or a negative to a positive. So what we're going to do now is do an interval chart, much like we did for the polynomial inequalities we did in Guide 5. So we're going to figure out from one side all the way to the other side, so from negative infinity up to my first value, which is -2. So this is my first interval. Okay, we never put square brackets around the intervals, always round brackets. Okay, so we're testing between these values. That's my first interval. My next one is from -2 to +3. And then my last interval is from +3 to +infinity. So those are the three intervals where the function can either be above the x-axis or below the x-axis. What we're going to do now is look at the factors that make up my rational expression. So x minus 3 is my first factor. X plus 2 is my second factor. And then when I divide x minus 3 over x plus 2, I get my rational function. So now it's just a matter of filling out this interval chart. Okay, we've done a number of these interval charts. So take a value between -infinity and -2, any value, -10. -10 minus 3 is a negative value. -10 plus 2 is a negative value. A negative divided by a negative is a positive. Anybody unsure what I'm talking about? Okay, take a value in the next interval, 0. If I put 0 into x minus 3, I get a negative. If I put it in x plus 2, I get a positive. A negative divided by a positive is a negative. The last interval, I put a big number in there, like 10, it all becomes positive. So now I look at my original question. My original question says, when is x minus 3 over x plus 2, when is that greater than 0? So what two intervals are, excuse me, I don't know, I just gave you the answer, kind of. What intervals, I should have said, is the function greater than 0? Kyle?
3 and
So 3 and +infinity, and which other guy? Exactly. Okay. So when is this? You can see right from your interval chart that it's between -infinity and -2, and -3 and +infinity. Okay. So essentially, what you want to do when you're solving rational expressions, rational inequalities algebraically, is identify the intercepts, identify the vertical asymptotes, write your intervals in order, write down your factors, decide whether they're positive or negative, decide whether your function's positive or negative, answer the question. Okay? This becomes a little bit harder when the rational expression has quadratics in it or cubics or anything else. So the same question, just a harder function. So I want to know when is x squared minus x minus 56 divided by x squared minus 16. When is that less than and equal to 0? Okay. Whenever you're solving a rational expression that can be factored, the first thing you should do is factor it. Okay, so before you begin to do anything else, factor it. It's an easy trinomial. On the top and on the bottom, I have a difference of squares. Once you have it in factored form, it's going to help you set up your interval chart, and also it'll make it a little bit easier for you to identify the x-intercepts and the vertical asymptotes. So the x-intercepts occur when the numerator is equal to 0. So when x minus 8 multiplied by x plus 7 is equal to 0. So that happens when x is equal to 8 or x is equal to negative 7. Then identify the vertical asymptotes. Vertical asymptotes occur when the denominator is equal to 0. And that would occur when x is equal to negative 4 or when x is equal to 4. Pretty straightforward stuff so far. No questions? So factored, set the numerator equal to 0 to find the intercept, set the denominator equal to 0 to find the vertical asymptote. Now I'm going to set up my interval chart. Okay, so I'm using these 4 values, and I'm starting at negative infinity, and then just listing the values in the order in which they occur. So I'll go from negative infinity to negative 7. Round brackets, right, because you're testing these are the intervals. From negative 7, bless you, to negative 4. From negative 4 to positive 4. From positive 4 to 8. And then from 8 to positive infinity. So there's 1, 2, 3, 4, 5 intervals where the function can be positive or the function can be negative. How we're going to decide that is using these factors. X minus 8 is the first factor. X plus 7 is the second one. That makes up the numerator. X plus 4. X minus 4 makes up the denominator. Because you're dealing with rational expressions, rational functions, it doesn't matter whether you multiply or divide first, right? So really what you're looking at is the number of negative signs. If you have an odd number of negative signs, it's going to be negative. If you have an even number of negative signs, it's going to be positive. So these 4 factors make up the rational expression that we're looking to solve. No, you could write it in factored form, either form. Doesn't really matter. Okay, okay, so then just quickly, negative 10 again I'll use. That's negative, 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 right? So I have 4 negatives, which becomes a positive, right? Because the top 2 factors are negative, which makes a positive. The bottom 2 factors are negative, which makes a positive. Positive divided by positive to a positive. Make sense? It really doesn't matter. You don't really have to worry about which one's on the top or which one's on the bottom. You just have to account for it. Okay? The guide does worry about it. You don't need to. A value in here, so something like negative 6. Negative 6 minus 8 is negative. Negative 6 plus 7 is positive. Negative 6 plus 4 is negative. Negative 6 minus 4 is negative. 3 negative signs, it's going to be a negative. 0, negative, positive, positive, negative. 2 negative signs, positive. 5, negative, bless you, positive, positive, positive. It's negative. Use 10, everything's positive. So it's positive. Okay, so the function is positive here, here, and here. The function is negative here and here. So the question originally asked me, when is x squared minus x minus 56 divided by x squared minus 16? When is that less than and equal to 0? So the function is less than and equal to 0 when, in what values? Yep.
-7, -4, and -4.
Right. Okay, so I purposely didn't write down the brackets yet because I have to account for different brackets now because of this equal then sign, right? So we know it's less than between -7 and -4, and we know it's less than between 4 and 8, but what's happening at those numbers? So at -7, is the function equal to 0? How do I know, Jordan?
Yes, it is.
Because?
Does it say intercept?
Right. So at -7, it's an intercept, so it's equal to 0, so I'm going to put a square bracket around it. At -4, is it equal to 0? Okay. Right. So I put a round bracket around it. Okay. At 4, another asymptote, can't include it. At 8, intercept, I can include it. So the final answer is the only time you're going to use square brackets. Okay? And a lot of people lose part marks putting square brackets in the top here, right? The only time you worry about the equal sign is in the final statement. That's when you use your square brackets, your greater than or equal symbols. Any questions on that? Okay, one last example. So I chose this example for two reasons. The first is what you do when you're solving an inequality when it has a number on the right-hand side. So if it has a number on the right-hand side, you can't have it there. You have to have 0 over on this side. So the first thing you're going to do is make the right-hand side equal to 0. Once you've made it equal to 0, now you just have to come up with your new rational expression by finding a common denominator. So x squared minus 4 x plus 2 minus the common denominator would be x plus 2. That means I multiply this top by x plus 2. Distributing through, I get x squared minus 4 minus 3x minus 6 all over x plus 2. Collecting like terms, I get x squared minus 3x minus 10 all over x plus 2. Okay, so there is a different way of doing this question, okay, but I wanted to show you that whenever you have a number on the right-hand side, the right-hand side always has to be 0, so you have to bring it to the other side, and then you find a common denominator and simplify it so you get your new rational expression. Okay. Any questions on this? Okay, so now what you would do is factor it, and then once you factor it, identify your vertical asymptotes and your intercepts and set up your interval chart. But, bless you, I chose this example because what happens when I factor? Sure? Right, I can divide it out, right? So I can divide it out providing x isn't equal to what value? Yep. Right, because that would make the bottom equal to 0. So I can do this providing x isn't equal to -2. Once I divide that through, then I end up with this question. How do I solve that? When is x minus 5 greater than 0? Do I need to do an interval chart for this? No? What do you do?
Whenever you bring the 5 to the other side.
Exactly. And that's the answer to your question. So when is x squared minus 4 over x plus 2 greater than 3? Whenever x is greater than 5. And remember to state your restriction. X cannot be equal to -2. So basically, to be successful in the this section, factor if it can be factored. Once it's in factored form, identify your intercepts, your asymptotes, write up your interval chart, solve your interval chart, answer the question. The only time you use square brackets is in the final answer, and you only use them to identify your intercepts, which is equal to 0. Any questions? Okay, so that is it.